Okay, today's lesson will be on lesson 3. This will be multiplying, dividing, and subtracting fractions. First example that we'll go over. Let's say we have 7 and 9 multiplied by 4 and 5. The first thing that you would do is just multiply the top by the top. 7 times 4 equals 28. 9 times 5 is 45. Let's see if we can break down the 28 over 45. We'll make our factoring trees of 28 and of 45. Let's do 14 and 2. It's 2 and 7. These are your primes. Let's do, for 45, we'll do 5 and 9. 3 and 3. We'll write this into our top fraction, bottom fraction. So 2 times 2 times 7. 3 times 3 times 5. We see that nothing cancels. Nothing from the top is on the bottom. So this is our simplified fraction. So what we have is 7 ninths multiplied by 4 fifths. Multiply the top, 28, or the 9 and the 5 multiplied together equals 45. See if it simplifies. Write out the trees. See if anything cancels. And that's it for this. Example number 2, 1/2 multiplied by 1/2. Multiplied by the top of the numerator together. It's just 1 times 1 is 1. Multiply the two bottoms together. 2 times 2 is 4. You can break this up apart. 1 times itself goes into 1. And then 2 numbers is 2 and 2. Nothing cancels, so you know it's 1/4. It's the simplest form of this fraction. 5/6 multiplied by 4 fifths. All you do, multiply by the top, it's 20. Multiply the bottoms together, it's 30. See if the 20 and the 30 break down. Make the factoring trees. We'll say 10 and 2, 3 and 10, 2 and 5. Then you just write these. This one being on top, so 2 times 2 times 5. This one being on the bottom, 3 times 2 times 5. You see there's one that cancels right there, and there's one that cancels right there. So you're left with 2/3. This reducing to 2/3. There's also a shortcut way. If you take 20 over 30, all you have to do is cross off the zeros. This would give you the 2/3. This only works with the tens, factors of tens. Because these are factors of tens, you can cross off the zeros. So if you have, say, 200 over 30, cross off 1 0 here, 1 0 here, and you're left with 20 over 3. You don't cross off all the zeros, so it's not 2/3 because you cross off this. It would be 20 over 3 for this one, not 2/3. Because you just cross the 0 on top from the 0 on the bottom, or vice versa, the 0 from the bottom from the 0 from the top. The reason why this works is if you break this up, this fraction up, and 2 multiplied by 10, break this up from 3 multiplied by 10. You see here, the 10s will cancel, and you're left with the 2/3. And that's what we're looking for. Say like you break it up and it goes 2 by 9 or 3 by 9. You can cancel those off. As long as the top and the bottom matches, they don't have to be prime numbers. As long as they're both multiplied by the same factor. So in this case, the factor of 9. So 2 times 9 or 3 times 9. You can cancel out the 9s and you're left with the 2/3. This would not be the simple form of this. just give me an example. Let's do some definitions. The definition number 1. A reciprocal is when you have two fractions that multiply together equal 1. So the product equals 1. So for an example, we have 1 over 2. The reciprocal of this is all you have to do is flip this fraction around, and that's the reciprocal. So if we multiply this by the reciprocal, this answer should give us 1. So if you multiply 1 times 2, this is 2. 2 times 1 is 2. 2 over 2, that just equals 1. And that's reciprocal. This number here, 1/2, this is the reciprocal of 1/2, 2 over 1. You just flip the fraction. Example 2, what is the reciprocal of 1/3? Once again, you just flip the fraction, 3 over 1, and just to check to see if it's the reciprocal, this answer should equal to 1. 3 times 1, 3. 3 times 1, 3. This equals 1. Reciprocals will come in handy, and they'll be very important of what we're going to be talking next about dividing. Now let's do some dividing of fractions. Example 1 of this. Let's say we have 2/3 divided by 1/4. Okay, what we got to do, we got to flip one of these. So what I'm going to do right now is we're going to flip this one. Take the reciprocal of 1/4, and then multiply that reciprocal by this. So we have 2/3 multiplied by the reciprocal of 1/4. So that would be 4 over 1. Then you just simply do your regular multiplication. 2 times 4 is 8. 3 times 1, 3. This can't be reduced, but it is an improper fraction, and we can talk about that in another lesson of how to do this. You can check to see if this can reduce by breaking the 8 into the factoring tree. And the 3, is a prime. So 2 and 4, and then 2, 2. So this goes on top. 2 times 2 times 2 is 8, and then this is on the bottom. So, it's simplified the most. You could also write this problem here, 2/3 divided by 1/4, as such. This, you can see to be a big fraction. All you have to do at this point is take the reciprocal of the bottom, the denominator, and flip that fraction, 4 over 1, and multiply it. And since you flipped it, and you got rid of it, you can take care of that line in the bottom portion. And now you just moved it up here. So this could also look like this, 2 times 4 over 3 times 1. Multiply that out, 8 over 3. And that would be your answer. Let's do another example. Example 2. Let's say we have 1/4 divided by 16. How would you do this? Well, you simply just say, what's the reciprocal of this? Well, that's easy. It's 1 over 16. You flip it, multiply it by this, and you get this. So you multiply the top, 1 and 1, and the bottom, 16 times 4, 64. That can't be reduced because 1 is a prime. Let's do another example. Last example for dividing. Let's say we're dividing 1/2 divided by 1/2. Now you're thinking, well, why is he doing this kind of problem? Well, let's see. Take a reciprocal of this, 1/2, or 2 over 1. And this would equal 2 times 1 is 2. 2 times 1 is 2. This equals 1. So just to recap, to multiply two fractions together, you multiply the bottoms together and the tops. So 1 times 1, 1. 2 times 2. For division, 1/2 divided by 1/2. take a reciprocal of one of them, say a 1/2, and multiply that reciprocal together with the one that you didn't flip. 2/1. Flip this, multiply it across, 2/2, 1. Adding fractions. Example 1. Let's take 1/2 plus 4/2. Now, you can add these together simply without changing the problem if the denominators are the same. So we have a 2 and a 2 here. So all you have to do is add the numerators together. 1 plus 4. And then the denominator stays the same. So you can write this as 1 plus 4/2. Because they have the same denominator, you can share them. So you just add them together. 5/2. 4 plus 1 is 5. And this stays the same because they're the same denominator, and it just goes over. Example number 2. Say we have 1/2 plus 1/2. The denominators, check to see if they're the same. Yep. So you just add the top together. 2/2. You know this is just 1. Example number 3. Let's say we have 1/4 plus 2/4 equals. Check to see if they have both the same denominator. They do. So you just add the numerators, the top numbers together. 3/4. Now, it could be a little more tricky, and we'll see a little more trickier ones. Example 4. This is going to get a little more tricky. So, what if we have 1/4 plus 1/6? Okay, so these denominators are not the same. So we got to think here for a second. We need to change these so they need to have a common denominator. Something that they have in common. We'll find out with doing the factoring tree of 4 and 6. So we'll go over here and do a factoring tree of 4 and 6. 2 and 2. And this would be 3 and 2. So the least common multiple for this, you have 2 here, 2 2's here, so you write those out. You already wrote the 2's on this one, so you just take the 3 from here. Multiply those all together and you get 12. This is the least common multiple. If you check out video lesson 1, you'll find out that we went over this in that section. This is also called the least common denominator. When we're working with fractions, that's what they call it. It's the same thing as least common multiple, but we're working with the denominators. We're trying to find something that's common with these two numbers. Now you know why we went through all that trouble with the least common multiple. So we take this, and we know the least common denominator is 12. How do we make 4 into 12? Well, you multiply by this 3, but you have to multiply the top by 3 also. Now you have to do the same thing on this side, but what multiplied by 6 will equal 12? What I can think of is 2. Multiply 2 by 6, you get 12. And you do the top and also the bottom. So you multiply those out, you get 3/12 plus 2/12. And now they have the common denominator. You can add them together. You just do the top, keep the 12 on the bottom the same, because they're the same. It would just be 5/12. You can't simplify this because we know that 5 is a prime. If it wasn't a prime, then you can break it apart and see which multiples can break off. You just do the factor tree for the 5 and the 12 and see if it cancels from the top to the bottom, like we've been doing before. Okay, example 5. Say we have 2/5 plus 3/10. Okay, the denominators are not the same, so we have to find the least common denominator. We know how to do that by breaking these denominators into factoring trees. We know 1 and 5, 10. We know 2 and 5. This, you know, if you take the 5 here, you can't take it from here. So you go I'm going to take the 5 from here, and the 2 from here, and the 1 from here. So 1 times 2 times 5, we know that to be 10. So the least common denominator is 10. Okay, so now we know that it's 10. What can we make to multiply this 5, this denominator, to make 10? Well, we know 2, so if we do the 2 on the bottom, we have to do 2 on the top. We know to make this 10, you don't really need to change anything, we can just multiply it by 1. That one will make you happy. So to do this, 2 times 2 is 4, 2 times 5 is 10, plus 3 times 1 is 3, 10 times 1 is 10. Now they have the same denominator. You can add the tops together and keep the same denominator on the bottom. 3 plus 4 is 7. So you get 7/10. You can't simplify this because you know 7 is a prime. But if you didn't have a prime, you make the factoring trees into the primes. Example 6. Say we have 2/3 plus 3/6. Find the least common denominator. Do factoring trees. 3 and 6. 3 is 1 and 3. 6 is 2 and 3. I'm going to take a 3 from here, and a 2 from here, and 1 from here. 1 times 2 times 3, 6. So 6 is the least common denominator. What can I multiply by 3 that will give me 6? Well, 2. Since you did from the bottom, you multiply 2 from the top. And this would just be 1 multiplied by 1. You can skip that step if you don't want to. So 2 times 2 is 4. 2 times 3 is 6. Plus 3, 6. You see that the denominators are the same. So you keep them the same, so you can add just the numerators, the top numbers together. 3 plus 4 is 7. We see 7, 6. 7 is a prime, so it cannot reduce. And this is improper fraction. You can change it later in a different lesson. So 7, 6 is the answer to the question. You can tackle this another way by looking at the problem to see if you can reduce any of the fractions before you try to find the least common denominator. You can reduce this 3, 6 into a different fraction that's more simple. So 3 is a prime, but 6 can break up into 2 times 3. We know 3 times 1 is also 3. So you see the 3's cancel, you're left with 1/2. So what we can do is bring the 2/3 plus 1/2. And that might be a little more easy to see that these are all in primes now. So if you multiply these two primes together, you'll get 6. So the least common denominator would be 6. Change this into 6, multiply by 2. If you change the bottom, you have to change the top. Also, if you multiply by 3, change the bottom, change the top. So this would be 4, 6 plus 3, 6. See, kind of ended up, this would be the same thing. Add the top, 7. Keep the 6 on the bottom the same, 7, 6. See, there's multiple ways to get the same answer, but you can reduce this, add them together. It may be easier to see. There's different ways to tackle a math problem. The next section we'll be talking about will be subtracting fractions. It's the same thing as adding, but it's just the numerators are being subtracted. So for example, example 1. Say we have 3/2 minus 1/2. Denominator is the same. You just do 3 minus 1. 2. Keep the same denominator, bring it over, 2. So you know this is 1. 2 over 2 is 1. Example 2, this will be the last example we do in this video. What if we have 4/5 minus 2/3? Okay. We know we need to find the least common denominator. And so we don't need to do factoring trees because you know these are prime numbers. And if you want to do the factoring tree, you could, just to show you. There's a 5 times 1. Can't think of any numbers else besides 5 and 1 would equal 5. And I can't think of any other numbers that it can multiply 3 besides 3 and 1. So you just take the ones. So 5 times 1 times 1 times 3 equals 15. So the least common denominator is 15. Alright, since we know that 15, we're trying to reach 15, what do we need to multiply 5 to get 15? Well, we can just say 3. Since we did that from the bottom one, we have to multiply the top one by 3. And let's try to get 15 on the bottom. Multiply that by 5. And also you need another 5 on top, since you did it on the bottom too. Okay, multiply that out. 4 times 3 is 12 over 15 minus 2 times 5, 10 over 15. You can write this also as 12 minus 10 over 15. So 12 minus 10 gives you 2/15. And this will be your final answer. You can't simplify that because there's a prime in there. Alright, thank you for watching. You can see more of our videos on mymathmanual.com. Also, we're going to be uploading in a couple of days a couple of exercises from lesson 1, so you can go back and some practice. Okay, thank you for watching.